Hey, here we go. We were talking about evolution, the theory of evolution, the puzzle of life's diversity. Okay, remember the total variety of all the organisms on the biosphere. What we're calling this thing right here is we're going to call it biodiversity. Remind me, I got a song for you guys. Okay, where'd all these different organisms come from? How are they related? Do you have any idea? Think about it. How are we all related? We just talked about genetics. What's the same between all living organisms? All right, so think about that. Okay, so the thing that's doing it is so the theory of blank explains where all diversity on the planet comes from. So, what are we studying? The theory of evolution. Uh-oh, that's not right. Evolution. Whoops, that's not right either. That's not right either. Okay, evolution. Okay, so you got the theory of evolution. Now, remember, I'm not asking you to believe in evolution or lose any religion that you might have. Just, this is evolution. It's something I want you to understand so that, well, one thing you'll do well on your EOCT, and that if you ever get in a discussion with somebody, you know what they're talking about. Okay, the person who contributed the most to our understanding of evolution was... Get to know this guy. You don't usually see him like this. You usually see him as an older guy. Charles Darwin. Charles Darwin. Or I like to call him Chucky D. Okay, Charles Darwin. In 1831, at the age of 22, he joined the crew of the HMS Beagle. And as a naturalist, and he went around the world. It kind of shows you right there. This is a better map. So he started in England, went down, bumped around the east coast of South America, checked out these islands over here, went up the west coast of South America, and then went to the Galapagos Islands. We're going to talk a lot about the Galapagos Islands. In fact, I think that's going to be one of our next things we write down. But anyways, so remember, evolution synonymous with Galapagos Islands. Okay, they went around the world, so these two ends connect, and went to Australia. Bada boom, bada bing. Went down the south end went through Cape Town. Boom, hit here. Went back up there to England. Okay, so during his travels, Darwin wrote thousands of pages in his journals, drew pictures of the things he saw, and collected a vast amount of blank that led him to propose a revolutionary blank about the way life changes. Okay, so the amount, a lot of, we could say evidence, or you could say data. Okay, either way, you got a lot of it. That's the main thing, okay? So you got evidence and data, okay? To propose a revolutionary theory. Theory, okay? On how the way life changes. Okay, so some of the questions that Darwin was looking at. Why do Argentina and Australia have different animals even though they have similar grassland ecosystems? So what it's saying is that here in Argentina and here in Australia they have the same ecosystems, but they have different animals. Doesn't make sense. Why would that be? Okay, why are there no rabbits in Australia? Well, now there are, because humans brought them there. And no kangaroos in England. Why have so many species disappeared? Because they found all these fossils, and they're like, where did these guys go? How are these extinct species related to living species? If you can answer these questions, come and tell me now. Okay, while on his voyage around the world, aboard the HMS Beagle, Charles Darwin spent about 1 month observing life on the... Here we go. Remember these guys, Galapagos Islands. Okay, he saw some unique animals, such as the finches and the tortoises. We'll talk more about the finches and the tortoises. That they were found nowhere else on the planet. Okay, so it's right off the coast of Ecuador. Alright, the Galapagos Islands are close together, but have very different, we're going to say ecosystems. Okay, some are hot and dry with little vegetation. Others had more rainfall and were rich in vegetation. Each island had its own blank plant and animal species. Its own specific plant and animal species. Okay, let's take a look at these tortoises a little closer. Okay, Pinta Island, well, let's look at this guy. This guy, look, he lives on a desert island, on Hood Island, and he had to reach up taller because he's eating up on plants that are taller than him. This one comes on a lush forest on Isabella Island, and it has a short neck because all it does is eat stuff off the ground. Okay, it was an advantage to have a long, stretchy neck. And this guy's kind of in between. Okay, so what kind of climate do you think this guy was in? Answer that. Okay, when Darwin returned from his voyage, he spent many years studying the specimens he brought back and thinking about all the things he had seen. I don't know if this was really his desk or not. Seems a little weird that he'd have a picture of himself on it. Darwin's theory of evolution. It was shaped by other people. For instance, this guy right here, who we're going to call, that's Lyle. Okay, this guy right here, who we are going to call, we're going to call this guy Hutton. Proposed in 1785, Hutton proposed that the Earth was shaped by geological forces occurring over very long periods of time and is millions of years old. You have to understand that at the time, they only thought the world was around 6,000 years old. Right now, we're thinking it's around 5 billion years old. Okay? So this was kind of revolutionary. Okay? Because if evolution is to happen, it takes a long time. Okay, now this guy, this is, as you see, Sir Charles Lyell. He proposed, or explains that the geological processes that shaped the Earth a long time ago, they're still happening. So basically that rivers and stuff are still eroding away and making canyons and stuff. Okay? So they're still happening. And all this stuff kind of makes sense to us now, but it was new and revolutionary back then. Okay, so a couple of ideas that shaped Darwin's thinking. Well, not this one so much, because we didn't really understand about continental drift and stuff until later. But this does kind of show how we could have some similarities between animals here and here, even though they're thousands of miles apart. So these had Pangea, which was a supercontinent, and now it's spread apart because of the continental drift. Just like we are right currently, South America and North America are moving kind of towards Asia, and Africa is moving away from us. All right. So remember chapter 3? No, we didn't have anything to do with that. Living things must compete for food and shelter. All right. This is in 1798, Malthus. Babies were being born faster than people were dying. He reasoned that if the human population continued to grow, sooner or later there would not be enough resources for everyone. Okay, so what he was talking about, right now we're up to like 7 billion people on the planet, and we think maybe we may not be able to get above 9 billion before things really start getting ugly. But in any population in the wild, they compete for resources, for food and mates and stuff like that. But food could be a big problem. And if you get that, then the people who can get the food, they're going to be the ones that are stronger, and those are going to be the ones that can mate. Okay, and that's going to be a very important thing to think about. Okay, so now this guy, in 1809, this guy came up with something that was pretty important and is resurfacing. So we might hear more about this guy. Okay, this is Lamarck. Alright, Jean-Baptiste Lamarck. Okay, was the first scientist to recognize that living things changed over time and that all species were descended from other species. Okay, and that things just changed over time. Like giraffes used to have shorter necks, but they needed to reach higher, and so they kept on stretching their necks up and up and up and up, and then they would pass on that stretched longer neck to their offspring. Okay, this was known as inheritance of acquired traits. Okay, we got two words in it. I don't know. Let me see. Acquired traits, and this came out the year Darwin was born. Okay, so Lamarck was a little older, of course, but it was revolutionary for the time because he's saying that species change and formed into new species when everybody else was thinking, "Hey, God made everything the way it was, and nothing changes." Okay, the male fiddler crab uses its first front claw to attract mates and fight off predators. Through repeated use, and of the front claw becomes larger, and the fiddler passes this on to this acquired characteristic to its offspring. That's how it works. Okay, and this is kind of like saying, hey, what's wrong with this theory? Lamarck didn't know about blank and how traits are inherited. And how traits are inherited. You know about genetics. Okay? If you lifted weights your whole young adult life and then you had children, would your kids be more muscular? Not likely. Okay, here's Arnold Schwarzenegger, and here are his children. Are they big and muscular? No. Okay, acquired traits we're going to say, not be passed to offspring. Although there is some discussion about this now, so keep your ears open. This might be changing, because science is always changing. And listen for epigenetics. That's what we're going to look at a little bit too, I hope. Okay, what's right with Lamarck's hypothesis? What Lamarck was saying was, Lamarck was the first to develop a scientific hypothesis about evolution and recognize that organisms are adapted to their environments. Okay, so that's important. So they're adapted to they're well adapted to their environments. And what we're going to look at is this thing called natural selection. Natural selection is, well, we'll see. We're going to do some different things this time. We're going to try and incorporate more technology into our classroom. So hopefully you guys like this, and hopefully we'll be doing more of it.